1, section 3.3. On this wonderful Sunday morning, it's cloudy. Oh, it's Saturday today? Yeah. On this wonderful Saturday morning, it's cloudy. Rules of differentiation. So let's pick one of the two. I'll divide with the red line right there. Say f of x is equal to 2x squared plus 3x minus 10. And we take the derivative of this because we can. Use the limit h goes to 0 of 2x plus h squared plus 3x plus h. This is also your review for the test, right? Minus 2x squared plus 3x minus 10, everything divided by h, which is further equal to the limit h goes to 0 of, now we expand, is 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 10 minus 2x squared minus 3x plus 10 divided by h. Cancel these, cancel these, cancel these. Equals to the limit h goes to 0. Each term which remains has an h in it, so we're going to factor it. So 4x plus 2h plus 3 divided by h. These two h's will cancel. And the final answer here would be, as h goes to 0, 4x plus 3. On the other side of the line, I'm starting with the same function, f of x equals to 2x squared plus 3x minus 10. And I'm memorizing formula which says that the derivative of the polynomials will be n x to the n minus 1. Which means that the derivative of this would be 4x plus 3. So now we can do, just like on the I exam, what's better, A or B? A or B? It's like the I exam, right? So what this lecture is about, 3.3. Exactly. Yes. 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 You will not see a question like this for 15 points on the final exam, but the answer to your question is yes. What we are learning in section 3.3 are a bunch of formulas which are all shortcuts, so you do not have to use the limit definition ever again. So the first time you think, the formulas, you can immediately quit learning them because you can always default to the limit. And the things are going to get much worse in terms of finding limits, so finding derivatives. So this limit formula will be extremely impractical. Could take up to 40 minutes to compute. So we are going to learn formulas which are shortcuts to finding the derivatives. Keep that in mind as well. So whatever you see today is the shortest possible way to do the derivative. Well, Mathematica, but then. So let's start. The first one. And I'm going to, let's first talk about notation. Notation. Notation for the derivative y prime f prime of x dy dx, y with a dot above, capital D, and there are others. These are the most common ones.
What is that y prime?
Y prime is the first one. So let's talk about these notation first. The first one, y prime, is probably, it's used a lot, but it's the worst notation you can possibly have, and we'll discuss why later. So you will very rarely see me write y prime. Very rare. Like if I wrote y prime, probably I had cake last day. No, that's bad actually. I had cake every day. Whatever. Y prime. Bad one. But then f of x prime, that's the very frequent one. That's the awesome one. Dy dx, the best one of all. Y prime, well, we are honoring our ancestor with that one. That's Newton's notation for derivative. And the only people who are still using this would be the mechanical engineers. So some of the old mechanical engineers, the old school mechanical engineers would use this. So when I took some of my engineering classes, a professor used y dot and theta dot and theta double dot for two derivatives and so on. The last one you guys are going to see in your linear algebra class, the capital D stands for derivative, but that's going to be like derivative as the operator, and it's going to be the part of some matrix and stuff. So that's also going to show up. You might also see that in your differential equations, depends who's teaching it, and you know. Now, important regarding notation. You are going to have a function as some blah over there, and for your derivative, you are either going to write f of x, f prime of x, or dy dx equals 2, and you're going to have the answer there. Has to be a new line, meaning you cannot go and say f of x equals x squared equals 2x as a derivative. Hell no. X squared and 2x are not the same function. You can't set equal between them. So you have a line for the function, and then you have to restart the notation with f of prime or dy dx or y dot if you want to be sophisticated. Don't. So it has to be the new line. Dy dx is the most powerful notation. It is that notation was given to us by Leibniz, who discovered calculus at the same time as Newton did, independently. And that notation is far superior because that notation tells you that you are taking the derivative of function y. Remember y is f of x? Taking the derivative of function y in respect to x. That's extremely powerful notation, and see how important it is as we move along. Those of you going to Calc 3, that will be like, wow. Also good notation because it tells you that you are looking for the first derivative of the function f in respect to x. Also good notation. This one, garbage notation, because it tells you that you are taking the derivative of y, but it doesn't tell you in respect to what. And what are you going to do if the function y has 3 letters in it, right? If it has a, x, and t, right? A, x, and t. You would go, well, okay, a's are usually parameters, so that should be a constant, right? Usually. But then which one is it? Is it x, which is usually kind of distances, or t, which is time? Also could be a very, right? All of your derivatives for velocities and accelerations and all of that, main variable is t, time. So you're taking the derivative in respect to t. So that's the reason why y prime is a garbage notation. It doesn't tell you what you're taking the derivative in respect to, and as soon as you get 2 different letters inside the function, well, it becomes like, right? So we're trying to avoid y prime as much as we can. We use f prime of x. We use dy dx. But now there is another part why dy dx is so awesome. Dy dx allows you to write the derivative in line with the function. It's the only one that does that. If I start by saying that f of x is equal to x squared, you know that y is equal to x squared. That's the precalculus notion that y is f of x, right? And I want the derivative f prime of x. Now look what you can do. You already know that the answer is 2x, right? So you can say, you're giving an instruction what to do. You are giving an instruction what to do. You say, find the derivative in respect to x. All that I said is right in there. Find the derivative in respect to x of, which means there is a multiplication symbol in between these two thingies. So find the derivative in respect to x of x squared. But you see that the entire notation here, don't you agree that this is your y? And if you have a times over there, that's like a dy. So this is already the notation for derivative. You can just say equal to x. It's awesome. So this notation here is possible because Leibniz notation. You write one or the other. One or the other. And you have to agree that this y over here is this y, which is that. So that's why we can write it this way. So if you want to write in line the function and derivative, you will use Leibniz notation in this way. And there's no way to do this with any of the other ones. Just Leibniz notation is working that way. And I put almost 100% of what I write like that, because I like to see what is the original function and where the derivative ends up. But then, obviously, some formulas, we will use the other notation. Awesome. So now that we understand how the notation works, we write our first formula, which we are memorizing because it's a shortcut formula to find the derivatives. And that one says the derivative in respect to x of a constant is 0. That's the first one. So before you leave, what's the derivative of 3? What's the derivative of pi? Thank you. What's the derivative of pi cubed? 0, because pi cubed is 3.14 to 3. It's going to be some number. Derivative of constant is 0. Awesome. So the example, the derivative of 7 is 0. The derivative of pi squared is 0. Next formula which you are memorizing is the one that I listed at the beginning. The derivative of x to some kind of exponent. Guys, this includes fractions, it includes whole numbers, positive, negative. So if you have this, the answer is n, x to the n minus 1. You will be subtracting 1. Immediately, what is the derivative of x to the 7th power? I heard 5. And I just can't get over it. Because 7 minus 1 is clearly 5. Now the next question is, how much is the derivative of a square root of x? Well, let's first rewrite it so that we can compute it as x to the 1/2, and then you unleash the formula upon it. What do you get? You are all so rushing to answer the question. None of those are still correct.
1 by 2 x with 2 1 by 2 minus 1.
None of those.
I mean,
Yes. So you have a portion of the answer and he has a portion of the answer, and if you combine it, if you fuse it together, you would have the correct answer. Because it's so difficult to subtract 1, I understand.
1 by 2 x with 2 minus 1 by 2.
Yes. Finally, it is 1/2 times x to the negative 1/2, which is equal to 1 over 2 root x. There we go. I know, awful. Subtracting 1. Since you did so well on it, let's do one more. What is the derivative of 1 over the 4th root of x? Meditate on that one. You have friends, ask, communicate. I'll be right back. Touch your chin. Wow. I can't unlook at it. Everyone is confused when algebra gets involved. And everyone is cool with calculus. Let me test that. What happens if the left limit and the right limits are the same?
And it's true.
Then the over limit exists, right? Awesome. Do we have a derivative on a spike? No. And how much is negative 1/4 minus 1? This is where everyone loses their minds. Yeah. All right. So if the algebra is involved, the whole hell breaks loose quickly, right? Guys, we're first going to rewrite this using algebra as x to the negative 1/4. And then it fits our formula up there. So negative 1/4. And then we have x to the negative 1/4 minus 1, which we have to compute, and that is negative 5/4. Thank you. So negative 1/4 x to the negative 5/4, and then we write it nicely, 1/4 4th root x to the 5th. I know, awesome. Do that in your notebook. Yes. If you can go immediately from the first step into the last, you're good to go. Yes. Right? What do you mean?
That's like
Ready for the next one? Yeah, you are. The derivative of e to the x is e to the x. The derivative of e to the kx is k e to the kx. One example will be sufficient. The derivative of e to the 5x is 5e to the 5x, and we move along. Now the next part is us figuring out some rules regarding derivatives. The first rule is the constant multiplication rule. where the derivative times the function, the derivative of a constant times the function is constant times the derivative of function. In simple language, you can kick the constant out. What is the derivative of 10x squared? So by this rule, you are allowed to kick 10 in front of the derivative and just worry about the derivative of the function, which is 10 times 2x, eventually 20x. Now, you will be skipping this in your heads. You will immediately go for 20x later in a course. But it is a rule. And we remember the rule. Bueno? Awesome. So what is the derivative of 7e to the 5x? What should I write first? 7 times the derivative, good. Which would be 7 times 5e to the 5x, which is, as you already said, 35e to the 5x right off the bat. You are allowed to go from the first step to the very last step once you get comfortable with this thing. I just need you to know why is it so. So we have that rule. Next rule is what happens if your function is e to the x plus x squared. So the function is made out of two functions which are added. So we have addition and subtraction rules, which says that the derivative of f of x plus minus g of x, so it's whether it's addition or subtraction, is equal to addition or subtraction of individual derivatives. So you will be taking derivatives separately of those functions. So what is the derivative? See you next week. 3x squared minus e to the 2x. So we are going to separate these two and do each one individually. So we have the derivative. Now again, you will be skipping these steps later on. We're just learning what is possible. Minus the derivative of e to the 2x. The first one is we kick 3 outside, and then 3 times 2 would be, so it's 6x minus 2e to the 2x. The sooner you get in a habit of factoring everything you can, the better. So before you even ask me, do we have to, the answer is no, but it's highly recommended to practice this because in chapter 4 will be yes. For chapter 4, most of the problems you will have to factor because you'll be setting it equal to 0 and doing stuff. So if you can factor anything, just factor it out. Practice those things. That goes for constants, goes for numbers, goes for for variables. X squared. You can factor it to the x. It's good. Right?
Yes.
Thank you. higher order derivatives. After the first derivative, there is a second derivative, and then the third derivative, and then the fourth derivative, and then the fifth derivative, and then the sixth derivative, and then the seventh derivative, and so on. How do you calculate sixth derivative? Well, you just take the first derivative of the fifth derivative. You have to have a derivative before, and when you take the derivative of that one, you will get the next one. So what is the progression for the second derivative, let's say for 5x squared? The first derivative would be 10x. The second derivative would be 10. The third derivative would be the fourth derivative. Note the change in notation. 0. The 101st derivative would be awesome. So let's go with a different function. Calculate 1376 derivative if the function is e to the x. E to the x. Great. See, now you can go and brag that you, the first day working with derivatives, calculated 1376 derivative in a matter of seconds. You know that Newton never did that? That stuff wasn't around when he was around. He knew what the derivative of x squared was. All right. So let's see what the textbook thinks this would be a good exercise, good example for you. Find the second derivative, 2 tick marks on f. If the function is given as 3x plus 2 e to the x. So what's the first derivative? Y minus, it's plus. And what's the second derivative? Okay, cool. Find the equation of the tangent line at x equals to 4 for f of x equals x plus square root of x. We said that the most important problem of calculus 1 is finding the equation of the tangent line. If you have the equation of the tangent line, you can measure the change. So there you go. Got it? find the equation of the tangent line, what do we have to find first? Slope for the tangent line. And what do we have to find the slope? Derivative. Awesome. So find the derivative. Compute the derivative at 4. That's your slope. Then figure out the y value. You have x is 4. Then you have x, y, and m. Plug all of them to find b, and there you go. See?
So what is
You are in S 349.
so there will be y equals to mx plus b.
What?
The equation of the line.
Y, yes, because the equation of the tangent line is y for x plus b.
Where m is 1 by 4, x is 4. So y equals to 1. So it will be
All right, let's take a look at the problem together. The derivative is 1 plus 1 over 2 root x. Because we said earlier that the derivative of root x is 1 over 2 root x. So we have our derivative. To find the slope, we will compute the derivative at 4, which is 1 plus 1 over 2 times square root of 4. And that is 1 plus 1 quarter. So the slope is 5 over 4. Yes. We already have the x value. Remember that we are looking for y equal mx plus b. I need to find b. I have m. I have x. I need y. Well, y equals f of x, so? Original problem. Very good. So y would be f computed at 4, which is 4 plus square root of 4, which is 6. So now we plug everything in the formula. 6 equals 5 quarters times 4 plus b. These guys cancel. B is equal to 1. And finally, equation of the tangent line is y equals 5 quarters x plus 1. And the problem is solved. Yes? Yeah, but why would you? The answer is yes, but why? Then do it. I don't care. You can. Well, yes.
Do we have to do it, find b and then plug everything in, or can we use the y equals m x minus a plus x?
You can use that if you know the formula, fine. That's it for this lecture. You need to learn the formulas that are boxed in, so you are not facing these long limits. Try to research how to find the limit of e to the x plus h minus e to the x over h, and then see how easy it is to take the limit, to find the derivative using the limit, let's say e to the 5x. How long will it take? What else you need to learn along the way, and so on. This section was section full of shortcuts. We learned about the derivative notation. We learned about the derivative of constant is 0, derivative of polynomial terms or any kind of exponent, whether it's a negative or a fraction for roots, is n x to the n minus 1. Derivative of e to the x is itself. Constant rule, so all of the constants can be kicked outside, and addition and subtraction rules. So that's it for this